Okay, so we are reviewing for Chapter 3. I promised I would get a video up online by the end of today. And I won't say their names, but I have two special guests in the studio audience today who are giving up their time to participate in the video. They might ask questions, they may not, but it's easier for me to talk when I have students in front of me. So for question number 1, identify the plane parallel to plane JKH. So it's a little difficult to see this, but H is that vertice right there. And to try and highlight this for you, because sometimes it's difficult to make a visual representation of a 3D figure from a 2D drawing. But what this is supposed to be is it's supposed to be a pentagonal prism. So there's a pentagon at this end of the prism, and there's a pentagon at this end of the prism. If you can imagine, you could stand it upright and it would sit with one pentagon. That's a very bad pentagon at the bottom, and one pentagon at the top, and it would stand kind of like that. So the side that is parallel to the pentagonal base is the pentagonal top. So that would be this right here. So I'm basically looking for a plane that includes 3 of those letters, because I could call that plane ABD, I could call it ADE, ACE, so there's a lot of possible choices here. So just looking through ABD, ABD. Those are those vertices, and they're all part of that top plane. So BCJ, the problem with that is J's down at this bottom. Okay? Does that make a little sense? Does the coloring help a little bit? Okay. Which segment is parallel to, that's read as line segment FE. And so that's right there. So since it's a line segment, you want to think about that as one side of a shape. I'm going to kind of, again, highlight. It's actually kind of the bottom of that side. So the line that is parallel to it is the top there, is DK. They don't have DK, but they have KD. KD is the same thing as DK. I can call this line DK, or I can call it line KD. It's a line segment that has those 2 endpoints. That one makes sense. We're rocking and rolling. I didn't want to clear the whole page. For questions 3 through 10, refer to the figure at the right and identify the special name for each angle pair. Okay? So if I look at angle 8 and angle 4, part of the problem is figuring out, like, where is the transversal and where are the lines that create them. So the transversal is going to be the line that both of them touch. That's the transversal. Okay? And then the 2 lines that that transversal intersects is line A and line B. So those 2 angles are outside, they're exterior of that, and they're on opposite sides of the transversal. So they're alternate exterior. Notice they're not congruent because these lines A and B are not parallel, but they're not asking us. They're just asking us for the name. For number 4, it's 10 and 11. So 10 and 11 sit on this transversal, but again, line A and line B intersect the transversal. They're on the same side of the transversal, so the word is not going to be alternate. So I can scratch out the alternate. And they're both on the inside. So it's consecutive interior. Corresponding would be if they were on the same side of the transversal, but one was exterior and one was interior. Okay? So for the next one, there was a typo on the review. We told you guys to find angle 11. So I have angle 6 and angle 11. and I'm told that S and T are parallel. So 6 and 11 sit on the same side of that transversal B, and they're both interior, so they're this consecutive interior, and you have to remember which ones are supplementary and which ones are congruent. Consecutive interior angles are supplementary, so they add up to 180 degrees. So if angle 6 is 80, I'm thinking about what number would I add to 80 to get 180? That's 100. So each time you do that, you want to think about what's the name, what relationship are they? Consecutive interior corresponding alternate interior or alternate exterior, and then which are congruent and which are supplementary. So for the next one, given that S and T are parallel, and the measure of angle 1 is 8x minus 4, and the measure of angle 9. So again, I have to say, okay, I'm told that S and T are parallel. That's S, that's T. They're cut by transversal A. So they are on the same side of the transversal, but one is exterior and one's interior. So do you remember what type of angles that's called? That's corresponding. And what's the relationship for corresponding angles? Are they supplementary or congruent? Do you remember? They're congruent. So I would write an equation, I'm going to just do this over here, where I would set these equal to each other. Whatever the expression, 8x minus 4, whatever that number ends up being, is going to be the same value as 6x plus 24. Now this is the other thing. Underline or think about, the question is asking me to just solve for x. So once I get the variable, I have the answer. Sometimes we have questions where they ask us to find the measure of an angle. Then we would have to plug it back in. So just reviewing algebra, I'd subtract 6x from both sides. I'd get 2x minus 4 equals 24. I'm going to give myself a little more space here. I would add 4 to both sides. 2x equals 28. So x equals 14. Okay, and that's the answer for number 6. I'm going to clear my annotations. And I'm actually going to reset the page because I need to look at that drawing again for number 7. Given that angle 4 is congruent to angle 12, they're telling me that. Which postulate or theorem justifies that S is parallel to T? So really, if I don't understand everything the question's asking, I'm just really identifying those angles. They're created by these parallel lines, cut by this transversal. They're on the same side of the transversal. One's exterior, one's interior, so they are corresponding. So I'm basically looking here for the word that says corresponding. The reason the word converse is in there is what we're actually saying is we're trying to prove that the lines are parallel. So if the corresponding angles are congruent, then the lines are parallel. So we've taken that then the lines are parallel and put it second. That's technically why it's called the converse. Ah, I keep clearing the page by accident. Okay, so for number 8, if angle 2 is congruent to angle 16, which postulate or theorem justifies? So I need to look back at this picture, and now we're talking about 2 and 16. So this is the line that connects them. That's the transversal. I can see they're on opposite sides of the transversal, so I'm going to definitely be looking for the word alternate. And these are the parallel lines. So I can see that they're outside the parallel lines, so it's alternate exterior. Again, it's the converse technically, because we're told that the angles are congruent, and then we're proving the lines are parallel. So if S is parallel to T by the alternate interior angles theorem, which angle pair must also be congruent? So I have to go back and forth between pages here, so I'm going to just I write down my choices. I have 8 and 2, 8 and 9, 8 and 7, and 8 and 10. And I'm looking for alternate interior angles. So let me go back here to the drawing. On your test, it'll all be on the same page. 8, and they're telling me I want alternate interior angles, right? So the other angle that's on the opposite side of the transversal but inside is 10. So it's 8 and 10. So that was really nice that they gave me multiple choice, but I didn't end up needing it. So, and then the next one, measure of angle 5 and measure of angle 12. So let me look back at my drawing and say 5 and 12. They're on the same side of the transversal, correct? And they're both interior. So they're going to be consecutive interior angles, which means they're going to add up to 180 degrees. So now, instead of setting these two equal to each other, I'm going to add them all together, and it has to equal 180 degrees. So now I have to combine some like terms. 10x and 3x is -6 plus 17. I can do it this way. I'm combining terms. So I can do -6 plus 17, or I can keep the positives with the 17 and keep the negative with the 6. Oh, 17 minus 6 is much easier for me. It's 11. Okay, so now I'm going to add 11 to both sides. I get 13x equals 191, correct? Now I need a calculator to divide. It's too early in the morning to do that longhand. 191 divided by 13. Whoa. That's not pretty. Did I do it all right? Okay, so I did all right. So here's the thing. When I made the review, I just typed in numbers. I don't think I made them all work pretty. Okay, so for this one, that would be the value, 14.69. On your test, it should be a much more even number. Okay, and I'm just double check that 5 and 12 were definitely, yeah, it definitely should have been. And I will do that whenever I like you see here, like if I get a nice whole number, I'm like, oh, I think the answer is good. If I get a weird number, like a decimal, a fraction, I check it to make sure. But in that case, this is the answer. Ooh, we're moving on to slope. How do we find slope? Y equals mx plus b is slope-intercept form. How do we find the slope? Do you remember? Do you remember? So this is the y2 minus y1 over x2 minus x1. Or basically, I'm just subtracting the y values, and then I'm subtracting the x values. I tend not to think about this formula. I tend to just say, okay, my first y in this first pair is -8, and in the second pair is 12. So it's y minus the other y. Because it doesn't matter which one is 2 and which one is 1. X minus the other x. So -8 minus 12. If you have a hard time with negatives, you think on that number line, -8. And then I'm subtracting, so I'm always moving to the left. So -8 minus 12 is -20. And 1 minus 5 is -4. A negative divided by a negative is a positive. They cancel out. So it's 20 over 4, but I can simplify that. 20 divided by 4 is 5. Reason it doesn't matter which way I do it, if I did it the other way, if I did 12 minus, now remember it's always 12 minus, the number is -8. So I have two negative signs there. 5 minus 1. 12 minus -8 is the same as 12 plus 8. So that's 20. And 5 minus 1 is 4. And 20 divided by 4 is 5. Okay, so that's number 11. Number 12, I'm just going to do this one a little bit faster. Negative 5 minus 2 and negative 6 minus 5. Negative 5 minus 2 is negative 7, correct? And negative 6 minus 5 is negative 11. So negative 7 over negative 11 is positive 7/11. We got those? Okay. And then these last two I did in class yesterday. It would have been smart of me to record at that time, right? Yeah. So for number 13, we're given point A and B. We need to find the slope of A and B, and then we got to figure out a point that D will have that same slope as C. And the reason I'm saying same slope is because the lines are parallel. So the first thing I'm going to do is find the slope of A and B. 5 minus negative 11, 2 minus 6. 5 minus negative 11 is 5 plus 11, correct? And that's 16. And 2 minus 6 is negative 4. So 16 over negative 4 is actually the same as negative 16 over 4. In a textbook, or where it's typed neatly, you'll see it as a negative in front of the fraction. But no matter what I do there, the answer is negative 4. So I want a slope of negative 4. So what I'm going to do now, realistically, the best way to do this is to check them all until I get a match. In this problem, I think the answer is actually A. But so what I'm going to do is I'm going to say C is 10 minus something, because the y value in C is 10. And then and then 3 minus something. So if I plug these values in, 10 minus 14 and 3 minus 2. 10 minus 14 is negative 4. 3, and that should say 2. See, I did the math in my head. 3 minus 2 is 1. So negative 4 over 1, that's the correct answer. If I hadn't done it, like if that hadn't been the first one I picked, let me just try it. So if I had said, like, say I had tried this one first, if I had put in 11 and 4, 10, sorry, I did that backwards. I'm getting excited. We're almost done with the video, and which means you guys can go do something much more enjoyable. 10 minus 4 is 6. And 3 minus 11 is negative 8. And negative 6/8 is definitely not the same as negative 4, so it wouldn't be right. For the last problem, the one on the review,